Everybody, welcome. Just a round of applause that you made it through the day. This is the last session, the grand finale. Woo! Following this, which I'm sure will be an incredible 30 minutes of knowledge, will be the reception in the expo hall. So I want to encourage you all to stick around for that. There'll be beverages, and also I'm plugging the community booth, which is so exciting. They're going to do a quiz, handing out all sorts of goodies. So definitely head over to that immediately following the session. But now I'm very excited to start our Ask Us, Ask Them, Ask Me Anything session with two of our best and brightest, and already I've been here a short time, but already two of my favorite people at MongoDB, Asya and Danielle. And fire away if you want to do an intro.
Do you say that about everyone?
No, just you two.
Just us
I saved the best for the last, the warmest for the last. But we have a microphone set up in the center here. If you feel like standing up, since it's been a long day, otherwise raise your hand and I'll burn some cows running the microphone over to you. So whatever works for you all, here we go.
And I want you all to know that we are well aware of the perils of standing between attendees and their happy hour, food and drink. So we're going to try to be as terse and brief as possible. But if you don't ask us questions, then we're going to have to make up some really terrible questions.
I would like to start off, because
Sure.
I didn't get to ask this last week. You've been to a lot of stuff today. You've seen a lot of speakers, keynote. For each of you, what would have been your best takeaway from the day so far?
I like the beer supply chain thing. I thought that was awesome. Because honestly, all of the other talks I've heard before, right? So I always try to go to the customer talks because I like to hear what their use cases are. And so, the beer to the truck to the train to the truck. The guy went choo-choo, and that one tried to deliver. That was just, it was a good laugh. I liked that.
That was the J.B. Hunt talk, if y'all want to look that up later on. That was sensational. Donovan did a great job speaking. Yeah, that was great. Danielle?
Best venue ever for MongoDB.local, and I still haven't had my beer.
That's true. The venue is amazing. Oh, and the trucks, the lunch. I know the lines were long and stuff, but it was just so much nicer than having your standard hotel buffet thing, What about you all? Oh, no, ask questions, and we'll talk about your favorite part during happy hours.
Yeah. Here, I'll bring it up to you.
Hey guys, how you doing? I have a. All right, so how do you tell? All right, so we define indexes from the most selective. We have a list of field join index, the most selective on the left, right?
No,
Not.
that's a misconception.
Okay, right. So how do you tell if your index from the explain is not optimal?
So the question ultimately is, how do you tell from an explain that the index is not optimal? And you don't actually need explain for that. Those of you who were in my talk, you can see in the log line or in Profiler or in a bunch of different charts in Atlas monitoring, you can see how many index entries were scanned relative to how many documents were returned. And ultimately, the peak of efficiency is for every document that's returned to the application, you looked at one index entry and no actual documents themselves. So that's called a covered index query, right? I say, I want all the documents where, first name is Asya, and I want the first name and the last name. And if there's an index on first name, comma, last name, right, we're going to be able to find all the entries where first name is Asya and find the last name right there in the index and return just those two fields just by scanning the index without actually having to go to the documents on disk. So that's like the ultimate, right? You're not always going to be able to do that because you usually have a lot more variety of queries than you can have permutations of different indexes. Explain will essentially show you the same thing, right? Number of index entries scanned, the number of documents read and fetched, and the number of documents returned. But I do want to address something you started saying about most selective, more selective, less. So when you have a compound index, there's this misconception that I have found, even internally among our own engineers. So if you have two fields in a compound index, which one should be first? So you index by A and B, which one should be first? Like if you have first name and last name. Anybody, yell it out. Which one should be first? I mean, I made it first name, last name so that there's an obvious answer. The obvious answer is last name. Why? What's that? No, that's not why. It's because sometimes you're going to search just by last name, right? How often are you going to search just by first name? Now, that's because of cardinality, right? You're never going to search by first name Steve because you're just going to get way too many results. If you search by first name Asya, you're not going to get that many results, but that's kind of an outlier, right? But let's say that, let's say last names didn't exist, just first name, comma, middle name, right? Or A, comma, B, where A and B are equally likely to be used alone. Or maybe they're never used alone. You always search by providing both A and B. So which one of them should be first? And what people frequently think is the more selective one should be first. And that's actually kind of wrong. So first of all, the way that our compound indexes work is we concatenate the two values together, essentially, internally, right? And once they're together, it doesn't matter that the first half of it has more values or fewer values, right? We're essentially looking them up as a single value. But indexes have prefix compression. So if you put the thing with lower cardinality first, you're going to achieve better index compression, which benefits you both in memory and on disk. Oh, this is very advanced. And internally, we argue about this all the time because somebody new will come in and they'll be like, but it makes more sense that the more selective thing should be first. And that's like saying you're going to find in a phone book somebody whose last name starts with an X much faster than somebody whose last name starts with an A. Well, yeah, if you only look at one letter, that's true. But you're not going to look at A, you're going to look at A, B, C, at the first N characters of their last name, right? You're going to kind of narrow things down more or less the same way because of the way that B trees work. So that's my comment and my wisdom about that. And you learned something super advanced, and the rest of the people out there don't know that now. So if this comes up in the trivia in the community booth, then you'll win the fancy T-shirt. What do you have to add?
I'm not sure if this is documented, ESR. That's another advanced concept.
Yeah, ESR actually is documented. I'm a little bit against that because
Is
then
it?
people start thinking of it as a rule as opposed to just a rule of thumb or a guideline.
Well, it is important to put the sort fields before the range, and it's a bit counterintuitive for some people. Yeah,
It
it's
depends on the database distribution. See, there's a problem with MongoDB. Everything always starts with
it depends. That's the answer to everything.
I hate it and I love it at the same time.
But I'm still a proponent of ESR, which stands for equality sort range. So if you're going to build an index, most of the time you want to have the fields on which you're doing the sorting to appear before the one you're going to do a range query. Seems a bit counterintuitive, but if you draw a graph of how the index key would be, you would realize why it makes sense. I'm going to give you this exercise. Usually.
Not always.
So this is where we disagree a little bit. But usually it's still good. You should still understand how it works. It's a kind of an important
But here we're
concept.
talking about two fields with
Yes.
equality on both.
Yeah, the question was about
Can I
equality.
follow up with that?
Sure.
Let's say there's ambiguity between your position, her position. That sometimes it's better to have the sort on the end, and sometimes it's better to have the range in the end. How would you tell from the explain which one won?
Experimenting something is the best way to get the answer. Yeah.
All right, so you experiment, what are you looking for?
measure it.
Of what? I mean, be specific.
Build the different indexes and see which one is the most.
So for those who may not be familiar with the terminology, we're talking about when you have a query and among other things, it queries by some field by giving a range. Let's say where date goes from this range to that range, but then it wants it sorted by some other field, let's say a different date, right? Somebody who was last active in the last 2 weeks, but then sort them by account creation time or something else like that. So the nature of B-tree indexes is, as long as you have equality, you can have as many fields there as you want. But as soon as you have a range or a sort, you're looking at a wide part of the tree, and you lose the benefit of subsequent fields being in deterministic sorted order, right? So if you think about it, if you're looking for a range, let's say first name, last name, right? You're looking for everyone whose first name is between letters A and C. Okay, that gives you a range of them. And then last name, also A and C. It's like, well, for every A, you have the full alphabet, right? So within each value, you still have to look at a little sub-range. But my point about it depends is if your range significantly narrows the total amount of data that matched so far, you can then afford to do that sort in memory, right? Because if the range limits it, let's say from 1 billion documents to 500 documents, you read them in sorted order, you might be reading the entire index before you get to the part of the range, where you find oh, they're all in sorted order, but I have to keep checking whether they're in my range or not. Even if a very small subset are in the range, then it can be beneficial to apply range first. That's right. And that's why I say it depends, right? That's why it's not a hard and fast rule. It's a guideline where sometimes you'll end up doing the opposite. You said you had a good example for the...
Oh, yeah, for the query. No, but for the query. For example, you're looking for all the people living in New York that make over 100K, and you want them to be sorted by their name. So that, draw a little diagram of that, and you will understand why, having the sort before the range makes more sense. But yeah, when the number of value, as I said, is small, sorted memory is not that bad. A sorted memory of a lot of things is really bad, and that's really what you want to avoid. And that's why you're using an index that gives you the sort order. If you don't get that, that could be expensive.
It also might depend whether you have a limit with your sort.
Yeah.
Right? Because if you have a sort with limit, as soon as that number is satisfied, you're done. But if there's no limit, you have to kind of keep going until you find all of them that satisfy.
Limit has a lot of implication, especially with sort. It always depends. So obviously, one of the things you really should avoid is collection scan. You guys are aware of that. Collection scans are terrible. Well, it depends. If you're scanning like a collection of 20 items, they fit in memory, they will always be in memory, but it's fine, it's fast.
All right, we have our next question.
So I rode down with Donovan from JB Hunt in Northwest Arkansas, and everybody loves the work he's doing in MongoDB, and he's so successful that we're going to have a lot more databases move from SQL Server into MongoDB. And so I'm not worried about his work at all, but I have a sister team of data governance people, and I'm an old school data architect, one place to insert, one place to update. And today, I've learned more about the data needs to reside, how it's going to be read. So how do I get the old equipment master data everywhere where it needs to be and still have one place to expire a trailer if it, is taken out of commission?
Yeah.
And I don't know that I want an answer as much as, do you have a reference or some suggestions of where I could go back home and say, okay, we need to look at this?
Honestly, one of the things that I noticed so I worked with relational databases for years and years. And what I found is there's supposed to be one system of record. And there sort of was, but then every team would just pull that data because they needed it to be denormalized a little bit differently because the completely normalized schema just wasn't good enough for whatever performance issue they were having. So, for a lot of organizations saying, okay, we're actually going to store it that way to begin with is just a way of acknowledging what was already happening. And updating things in the official system of record became a matter of engineering discipline, right? unfortunately, there's not, ideally, you want to have like one system where the writes are coming in, all the other systems are pulling and transforming data because they need to read it differently. Usually, I don't know, and do you have many different systems that are writing to the data, or most of them reading and only few of them are writing?
Yeah, we have everything. We've been a mainframe DB2 for decades, and they're trying to modernize that. So we have legacy, and we have the new master data system, and then we have all kinds of data lake, and it's kind of like a data merry-go-round. But we're trying. That's why I kind of
data swamp.
Well, it's just the transitioning from old to new. We're right midstream, so. I've got a friend who is in charge of legal holds and purges, and he's just about to get his arms around relational, governance, but he's going to have to hustle quick or they're going to get away from him, I think.
Yeah.
Is it just a matter of cataloging?
Yeah.
Okay.
Yeah, in part because the fact is with relational, unless you literally only had one physical system, that danger always existed, right? That the data would get updated in a couple of different legacy systems and they didn't actually talk to each other. Then you pull them into some reporting thing and you're like, I have two different two different values for the exact same thing. Which one's right? And that's when the whole data cleansing started coming in, right? So I think this is just planning for it from the start. You have some suggestions? No? Yeah.
Thank you.
Honestly, this is the kind of thing where other companies that are going through the same thing can probably give you better advice on, or I guess our consulting engineers who work with those companies, they can tell you like, here's what this company ended up doing and it works okay. Honestly, until everybody's gone through it, we probably won't know which way might have worked best for everyone. And it also might not be the same thing simply because different organizations have historically have very different approaches and very different ways of dealing with how to enforce that sort of thing. So
Another question? All right.
cool. More hands are going up. Yay. Hope it's not about triggers.
Can you just hold it close?
Hi.
Hi.
So what would your recommendation would be for someone who's a beginner on Mongo in terms of the schema design? Would you recommend doing more of a embedded document design? Mostly our entities are sort of one-to-one, more than one-to-many. We do have one-to-many, but so what would your recommendation would be, to have more embedded documents or have specific documents for each of those entities?
I think that the solution you're going to pick doesn't have to, it's not related to the fact that you're new to MongoDB or not.
Okay.
I will say if you have a lot of experience in relational database and none in MongoDB, some trainings. I like to point people to M100, which is a course on university.mongodb.com. It's a 2-hour course, no exercise, very easy to go through, and maps your knowledge from the relational world to MongoDB. It's going to get you started. Going to get you started on thinking in documents, and that is probably the thing that you need to get to. Where you would prefer embedding versus linking is to keep things simple. What I like to say is, try to keep the data organized the way you're using it in the application. So mapping is direct, whatever object you have in memory, you just dump it to the database and that's how it's stored. So if you want to quickly get going on the solution with MongoDB where you don't have performance requirements, that's probably what you should be doing, embedding in that case. But it has nothing to do with your skills,
Okay.
I'll give an example of the very first MongoDB program that I wrote. I was migrating some data from a relational system to somewhere else, and I needed to pull it down and do some massaging of it. I was using Python, so it was like, install PyMongo, import PyMongo. It was just like so simple. Things just mapped into dictionaries. But then I was like, well, okay, should this be a dictionary with a list of dictionaries embedded? Or should this be a dictionary that references this other dictionary, right? And at the time, I decided to do it a certain way. And then later, as I learned more about MongoDB, I was like, oh, I probably didn't do it right. I probably should have done it the other way. And then as I learned more about MongoDB, I was like, you know what? I probably did it right the first time, right? And when I knew a little, but not everything, I thought, and then of course, ultimately, neither way is either right or wrong. I could have accomplished what I was doing with either method, right? But I ended up doing the thing that Danielle just described, which is just, okay, that's the entity, right? There's an entity and there's a bunch of things associated with it. It wasn't a huge system, so I didn't have to worry about endlessly growing embedded array, right? Because you don't want embed things that are going to grow forever, because then you got these massive documents eventually. You don't want to embed things that are not going to be relevant, right? But for other things, you absolutely should embed them, right? If they're logically kind of part of the parent object. Somebody asked me a long, long time ago, what I thought the mistake that people made when first using MongoDB. And I said, well, I'm going to guess that they either over-normalize, right? That they either take their normalized relational tables, move them over into MongoDB, and then they go, I wonder why my performance kind of stinks. Why are people so excited about MongoDB? It's a terrible relational database. It's like, that's right, it's a terrible relational database. But on the flip side, there are people who would embed everything. There are some examples, and there's a blog post, a fairly famous one from years ago, that says, it's titled, Why No One Should Use MongoDB. And it describes how they embedded everything and how then they got end-played into this, like not being able to use their data fully. And I go, they really should retitle that blog post, How No One Should Use MongoDB, right? And so both extremes are wrong. Where you land in the middle there, it just kind of depends. And there's probably like a sweet spot in the middle that you could embed or reference. Probably either would work for a lot of the cases. It might not even notice the difference until you're trying to like mega scaling. So I wouldn't worry too much about, oh my God, I'm not getting the schema perfect, because there's no such thing.
Yeah, and the nice thing with MongoDB, it's easy to change the schema after the fact if you need to. So, but the closer to the good solution, the easier modification will be after, obviously. If you base everything on articles and it should have been on people and everything is embedded in people, modification will be a little bit harder, still possible without downtime.
All right, yep. Manan just came in. Do you have a question? You had a question, right?
Yeah, so maybe it's not a schema design question, but since it's Ask Me Anything.
Asya knows everything, so
yeah,
it's not a
yeah,
problem.
So there is what do you recommend for the best practice of during cutover of like when we are migrating into Atlas? There is something called cutover, right? So what is the best practice to minimize not only the downtime, but also minimize the risk of something not working out, and like if you want to go back to your your original system, like what do you recommend? Like one is dual writes, but like the cutover, what is the best practice for cutover?
I think he's pointing. You're talking about live migration. When
migrations, yeah.
Live migration.
After the migration, there is something called cutover, right? So
when you're ready.
Sorry.
Yeah. So the whole idea of live migration is you have data coming in and it's going to your old system, but you're also writing it to the new system. Right, to get to that point, you have to replicate all of your data in the existing system in, let's say you're moving to Atlas, in Atlas. And if you're familiar with how the oplog works, right, it's, essentially copies all the data, then it replays the oplog. And now all of the new data that's coming in is essentially being written to one place, but it's also being written to the other one. The idea being that at some point when the second system is caught up to the first system, you momentarily stop, you pause to switch your application to start writing to the new place. And in a perfect world, in an ideal perfect world, you're done, right? Your old system is there, you can retire it now, and you're writing everything just to the new system. What some people have done is they essentially set up the equivalent of a two-way live migrate, where when they cut over to start writing to the new system, they now replicate those writes into the old system to maintain it to be exactly one-to-one parity with the new system in case they need to cut back over. Now that's a lot more work than
How do you copy the new data from Atlas into, because it's like
you tail the oplog exactly the same way.
You tail the oplog.
Right, the
okay.
oplog is on both sides,
it's
right?
a lot of work. Right?
Now,
Yeah.
now we've had people who were migrating from not MongoDB systems into MongoDB, trying to use the equivalent, and now it's a lot trickier, right? Because you have to essentially write to both places. Your application has to be smart enough to send writes to both places,
Right. But
right? And that's a lot of work on the application, right?
Yeah. So we do you recommend dual writing rather than copying the oplog over? Like if the at the application layer, if you can just write.
I recommend it if it's the easiest way to get the job
Yeah.
done. I'm very agnostic as far as like I don't have a you must do things this. It's like whatever works, right? I also don't
Yeah,
think you should use MongoDB for every single use case you have. You have some other database and you know it and it works
the source
well.
is MongoDB,
You should use that.
so
you know?
it's going into
Oh,
Atlas. There is no
Salespeople are in the room.
question
You would
about
hear
it.
them fainting right now.
Yeah, to summarize in terms of advice on that, I will say try to stay a little bit longer on your first system and double check that everything is fine in your Atlas one. It's easier to stay in that situation a little bit longer than go back to the original ones once you decide to cut over. So make things easy for you. But if it's really, really important, you can tell the uplog and replay those in the other system. You can have your application. If your application has a very well-defined layer where it writes to the DB and it's only 1 to 2 collections, you can also prepare the code. So once you cut over, it will continue doing the write on the old system, for example. So there's different strategies, but they do incur some changes in the application in preparation. The cheapest one is do all your, your verification in Atlas before you decide that you're ready to cut over.
Cheapest one is you cut over and you pray.
Oh, that's going to be a long discussion here.
We have another question here.
Yeah.
Sure. I think I just want to add a little bit to, I think live migrate and flipping the direction of the migration might work only if it is Atlas cluster to another Atlas cluster migration. But if it's from on-prem to Atlas, then he has an option of using Mongo Mirror, or I think there is a new utility called cluster to cluster synchronization that works only with MongoDB 6.
That's literally why cluster to cluster was turned into a product, right? Is because before consultants had to write these scripts that would essentially do that on either on top of Mongo Mirror or from scratch.
No, you need to set up two instances like.
Yeah, good point. Good point. Sorry, my bad. I should have plugged the new product, cluster to cluster.
Sure.
I forget. It's been way too long since I've worked with sales. Yeah.
And if I may ask another question,
Yeah.
Again, it's not schema design related. Like when the MongoDB does a failover from primary to secondary for whatever reason, MongoDB favors availability over data loss, right? Is there truly a way to prevent a data loss, like when doing a failover?
So is the question how to minimize data loss when there is a failover from a primary to a secondary?
Yeah, minimize, and then if possible, are there any ways to even not have a data loss?
Well, I mean, yeah, sure. If you always use majority right concern, right? So W majority, which is the default starting in 5.0, but it was the default on the Atlas connection string since like, I don't know, 2018 or something. So the idea is this. When you say you don't want data loss, what I hear you say, hopefully, is you don't want to lose data that has been acknowledged as successfully written, right? Because if you send the data to the cluster, and it gets lost, if it was never acknowledged, that's just the fact of life, right? You might have lost a network connection to the server and it never even arrived at the database. We don't really consider that data loss because, that's just flaky networks, right? But if the data is acknowledged as having been written, right, to the client, you don't want that data to disappear. And if it was acknowledged with right concern majority, meaning the majority of the cluster has committed that data, then when you lose your primary and there's an election, the secondary that's most up to date is going to become the new primary, and it has that right, right?
Yeah. What about the edge cases? Because even though you are saying a right concern majority, right? But ultimately it's writing to the primary first and then asynchronously writing to the secondaries, right? So you completed the write to the primary, but never completed the write to the other secondaries.
Then it hasn't been acknowledged to the client yet.
But your data is still there in primary, right? So how
It's
do you?
not. So the point, what does it mean that it's there? You just lost your primary, right? It's not there.
Yeah, but then what you are essentially telling me is, like, I have this rollback BSON now, right?
Yeah, don't worry
and
about the rollback. Think about this way.
Sure.
Since 3.6, by default, retriable rights are enabled. Oh, since 4.2. 3.6 is when we introduced them, 4.2 enabled them. Retriable right means the client, when it doesn't get back a success, or gets, let's say the primary went down and so we lost the connection to the primary, the driver will now say, hey, I should see if there's a new primary and retry this right to that new primary, which is the secondary. Now, if that secondary had that right, it's just going to give a success and say, yep, I got that right, it's been committed. If it didn't, then it's going to take it as if it's a new right and then reply whether it's successfully committed it or not. The point is that that right, it doesn't really exist until it's been acknowledged back to the client, because the client, whether automatically through the driver or in your own code, if it doesn't get back a success, it's going to do something. It's going to retry the right. It's going to wait to, until the timeout or whatever, right? And then it's got some business logic that says if this right fails, what do we do? Do we try it again? Do we write it to some side place, right? The idea that behind the scenes it actually may have been written to the primary before it crashed is not really relevant, right? Because that machine might not be back up for days. And your application has moved on. It has to, right? Because your users can't just sit there and wait while you figure out, does that primary come back up? Or is that hardware bad and you should just provision new hardware? Because then it's just going to come up and it's going to catch up from whatever the new primary is, right? So you can just ignore the rollback. If not losing data is important, you should never even think about looking at the rollback, because that's data that hasn't actually been committed from the point of view of the client.
Hold on. Yeah.
But not in the cluster.
Yeah, we're
we're
past
out of
time. I
time.
want to fit in one more
Yeah.
question, okay?
Okay, let's
Thank you.
squeeze one more question in. Then we can go and argue over beers and drinks.
In RDBMS, we have like a before and after snapshot. We can use that to create audit trails, right?
Of what? Of each individual row?
Yes, yeah.
Okay.
What about in MongoDB? What is the best practices to have?
I mean, if you really want something like that, you can use change streams with pre and or post images. But we have auditing as a separate feature that you can just turn on. So, I mean, depending on what you want from the audit trail, I would probably say use that.
This is for maybe analytics, right? So.
Oh, yeah, no, don't use auditing for analytics.
So I think one of the things is trigger. We can have a trigger on the collection, right? But I hear that that's not reliable because it uses the oplog and...
It's absolutely 100% reliable. What do you mean not reliable? Oplog is what we use for replication. It's probably the most solid part of the entire cluster.
Yeah, I think so. But, we were told by, MongoDB consultant that, it's not a good way to use the triggers to capture...
Wait. Did they mean don't use the oplog directly?
No, don't create triggers on a collection to capture the before or after snapshot of a document just got
All right,
changed.
I need the name of this person because clearly they need to be trained.
Okay.
Either that or they may have meant something else, right?
Because
so a lot of times I don't have the subtlety of, the context that they got from a full discussion that you may have had, right?
Yeah,
Because there are
just-
cases where, oh yeah, don't use this for X because something else might be much simpler, right?
No, we were told like we have to handle it in the application like a multi-transaction. You insert, and once that is successful, then you insert it into a history table. So that kind of it's not a normal. We do it right in
I
the
have no idea.
application development. So
Yeah.
usually we are used to create a trigger on a table and then take the before or after snapshot and insert it into a history table.
Yeah, I wouldn't go by what you do now with a relational system. I would go by what are your business requirements, right? What do you need?
yeah.
Like, and the business requirements are never expressed as we need to compare before and after image. The business requirements are we need to know when, somebody does something, or we need to know when, this
the
data
business
does
requirement
whatever,
is
right?
like who
The other
changed
stuff
the
is the
data,
how.
right? Who changed the data or inserted that data?
That's
the
audit trail.
audit trail.
But that
So-
has nothing to do with the op log. There's no information in the op log about the user that made the change. The op log is strictly about the data layer.
Yeah, in the data layer, we will have a field which captures from the application who changed it, right?
Yeah, then
So-
it would be available,
yeah,
right?
yeah. So in that case, if we just have a trigger on a collection and capture that into a history collection, that's very simple, right?
You work
But-
for some company that's very paranoid, right?
She works for a bank.
No.
Well, we have lots of banks that
No,
don't
the-
have a requirement.
Well,
Care about change,
Yeah.
identifying all the changes.
Okay.
yeah.
Banks are suffering
Sure. Anyway,
Say now,
so,
but
so
maybe at the
yeah,
end I will tell
I don't agree with what the consultant said in general, but there may be some nuances to some specific use case that you were describing that made them think that something isn't a way to do it. But
No, the consultant is from the MongoDB. Your consultant told us that we shouldn't be using the.
But presumably they said
triggers.
that because they thought of some better way to do it, right? Whenever there's a better way to do something, I'll tell you, don't use X because Y is better for your case. That doesn't mean X is bad. It just means for your case, Y is going to work better for some
Okay,
reason.
maybe after this, maybe
Maybe.
we can have more talk
We have
on
asked
that.
the expert. Oh, I guess they're done for the day. They're drinking too. Yeah. All right.
That was
Thanks,
great.
y'all, for coming.
Thank you for all the questions
Thanks for staying
/arguments.
this late
It
and
was
for not
awesome.
rushing off for the beer.
Round of applause for Asya and Danielle. And also, I just want to thank Maria Black, who pulled the room together all day, who's back here, and our awesome AV team. Thank you so much, all. We'll see you in the expo hall at the community booth over beverages. Thanks for being here.